All right, good morning, everybody. It's my pleasure to be here. Justin, thank you so much for inviting me. And Ganesh as well, thank you. First conference on developer portals, very exciting topic. I'm looking forward to exploring this with you over the next 40 or so minutes and talking about some history of developer productivity and also what's going on today and maybe the future of developer portals. So this is a little bit of an outline of my talk, so a little bit of a warning. First of all, I should let you know I'm an academic mostly, but I've worked a lot with industry. Over the last years, I've worked with IBM and Microsoft and DX and Multitudes and other companies as well. But I've been an academic and I teach, and I tend to go at a pretty fast pace. So I'm going to be going at a pretty fast pace this morning. So I hope you had some coffee and that you managed to, we're going to get off pretty fast here with some stuff. So to orient you, I'm just going to give a little bit of an overview. So I'm going to talk a little bit about the rise of developer portals. By the way, developer portal as a concept is something that's fairly new to me. I haven't studied it a lot in my research, but I have looked a lot at developer experience dashboards or developer productivity dashboards. So I'll be talking more a little bit about what I'm familiar with. And then I'm going to talk about some theories, frameworks, and metrics and why those matter, and why thinking about what those terms mean matter as well. And then we're going to look a little bit and have a little bit of fun at the end and talk about the future of developer experience dashboards and also the future of portals. So let's start off with the rise of the developer portal part of my talk. So as I said, this was a topic that wasn't that familiar to me, so I did some reading to see how people were defining it. And this was a definition that I put together from the different things that I read. So to me, my understanding, maybe I'll be corrected during the rest of today, is that it's this one-stop place to access services and APIs and the tools that we need to use. And through that, it supports our orchestration and our coordination of those services. And the part that I got really excited about is that it is a community. It's a place for people to meet, for developers and engineers to meet, to exchange knowledge about how they use tools and practices, and to help other people on board to these as well. I've studied quite a bit what's called a participatory culture of software development and open source, and I've always noticed that in industry space, there isn't so much of that community, so I think these portals provide that great opportunity. And of course, these portals are all about monitoring how people who use processes to create products actually do their work. And then this monitoring part is probably why Justin invited me, because I've been looking a lot at developer productivity metrics and a lot at developer productivity dashboards as well. So to talk about the monitoring part, because that's something that I've had more experience with, we can think about that the monitoring capabilities are to understand what is happening and to understand what can be improved, and to understand how to improve and determine if we actually improved. And I showed a picture here from the America's Cup control room because they use dashboards. Any sailors here in the room? I like to sail. I don't race anymore, but they use these dashboards basically to collect a lot of telemetry data and weather data and data from the other boats to see how they're doing. And the big point of it is that they don't collect this data for the sake of it. They collect this data because they want to improve, they want to win, right? So they're constantly kind of using that data to change what they're doing and to do better. And this data doesn't just come from the sensors that are on the boats or the weather sensors. This data also comes from the crew, right? The crew have a lot of knowledge about what's going on, and they share those insights with the team afterwards, who then decide how can we do better next time, and how can we not capsize, because that sometimes happens. So this information becomes critical. So going back, so where did all this sort of developer productivity stuff come from? So Justin suggested that I look, at the history of where this developer productivity stuff came from. And all of you probably are too young to know about this conference back in 1968, the famous NATO conference on what was called the software crisis. And I was reading the documentation from this conference a few weeks ago, and I'm like, oh, we still have some of the same problems. We're still trying to understand what is the best things that we should be doing. Of course, there was a lot of focus back then on programming language, still is today. But there was a lot of sort of focus on what are the things that we should be measuring, such as reliability and conformance to standards. And a couple of decades then after that, there was, this feeling that if you don't measure it, you can't manage it. And this was kind of well accepted. But of course, it was hard to measure stuff in the early days of software development. And DeMarco, some years after, he said, if you can't measure it, by the way, other people have said the same thing. But it was some years afterwards, he said, you know what, the only metric really worth counting is defects. Like the rest of it, we just don't have a good handle on it. And around the same time, he also wrote a book called Peopleware, and that's maybe partly why he said this, because a lot of the factors that influence how we engineer code is about people. It's about the social factors. And those are hard to measure, and they still are, but they still matter a lot. Then some years after that quote, that the only metric is defects, in the academic world, there was a lot of buzz because repositories were now collecting all of this data, telemetry data. In fact, we have an entire conference called Mining Software Repositories, which kind of makes me chuckle a little bit because that's just a method, right? It's not about something, it's about what you do to understand something. And there was a lot of work in the academia and a lot of ideas. I was, also playing around with this data, and we were generating these dashboards to give insights into what was happening, awareness about what was going on in these projects. Today, these dashboards you will see them all over the place in a lot of big organizations. This is a copy of a dashboard from Chaos, which has been around for a few years. It came out, it emerged from some of the folks that developed a tool called Bitgeria. I don't know if anybody knows about Bitgeria, but it was kind of one of the first kind of really developer kind of productivity dashboards that was out there, and it collected all of this data. And these dashboards are doing an okay job of showing how people use processes to create products. So they show a lot about that process of using the processes and the tools that we use and the speed at which we go through the system. But I would say that we're still lacking a little bit of the data about the people and how they feel and what challenges they have and how they're collaborating with each other. And even not enough about the products, how much technical debt, how many security vulnerabilities and so on that we might have in those. There are some, I'm not saying there aren't any, but in general, when I look at a lot of them that are out there, I see more of a focus on the process part. I'm going to come back to this point later. So now I get into the kind of academic part. So thank you for bearing with me and not getting up and leaving when I use the word theories. I want to talk about theories, frameworks, and metrics, and end up with metrics. So let's start with theories. So a lot of people kind of disagree with what the word theory and framework means, so I thought I'd give some representation or definitions of what they mean. So we use a lot of theories in software engineering, and not just in academia. We use them in industry all the time. In industry, we often hear a hypothesis maybe more than theory. And we have three different kinds of theories that we try to form in academia in particular. We have descriptive theories that say what is happening. So what is happening, say, in a project when we adopt a new tool or when we change from working in the office to working at home. We have predictive theories, what will happen if we do something. So what will happen if we no longer have testers and developers are testing? That could be a predictive theory about what's going to happen. And a prescriptive theory is what should happen if we do something. So if we use developer portals, these things will happen. So we have these three different kinds of theories. Now, the elements of a theory, and this is going to be important later, we can think of, first of all, the constructs are the entities, the things that we care about, the phenomenon that we're studying. So a construct could be developers, it could be the tools that they're using, it could be, let me use a code review example, it could be the code review tool, and then it could be the quality of the software when they use these tools to do code review. And then the relationships between them are the fact that these developers are using these tools to develop software. And the software, we may say that it's going to be of higher quality, and that is what we're saying is our proposition, that if developers use this code review tool that, say, reorders the files that developers review the code in, that it is going to lead to higher quality. That is our proposition. This theory is putting forward propositions like that. Now, what's really important, though, is not just that there are these propositions. So when I first started doing research, and I was reviewing papers, I noticed that a lot of people were just evaluating tools and saying, look, my new tool is better than tool B, but they never explained why. They just ran some tests, and they never showed why. They never said why this tool is better than another. It was sort of left implicit that, well, it's the latest new cool tool. Of course it's better. So theories offer this why. And for example, with the code review tool, by reordering the files that a developer is going to review the code, what that does is it lowers their cognitive load, right? So that's kind of the explanation of the why that comes with the theory. And then, of course, we also need to define when and where and how or what of the scope of the theory. So if our theory comes from just looking at small programs or looking at small teams, then we can only say that our theory is really only holds for that scope. All right, so what do we make theories about? So let me share this design science kind of frame with you. So design science is more of a frame for looking at the way that we do research. So when we think about theories, particularly in software engineering, we can think of them in terms of what we know about the problem that we're trying to solve and what we know about the solution to address that problem. So we have theories on the problem side, we have theories on the solution side. Now, when we do research, and you folks do research all the time in industry, you're constantly running experiments, you're constantly talking to engineers to understand, we can think of doing research first on the problem understanding side, where maybe you do surveys, maybe you interview developers, maybe you just observe them, maybe you just have lunch with them and talk to them. And you learn more about the problem that they have. And that helps you build this theory about what that problem is. And then once you know what that problem is, then you have requirements for fixing that problem. Maybe it's a new tool, maybe it's a new way of doing things, maybe it's, advice not to do something. And so then we have this solution, which could be a tool, it could be a process, could be a set of guidelines. And you may evaluate that solution independent from any real developers. You may just check that it works. You may check analytically it's doing the right things. But if you apply that solution to a real problem instance, you're validating that the tool that you created actually addresses the problem that you've identified. Now, once you've done that, once you've sort of clarified what the problem is, once you've got a solution and you validated it, this leads to what we could call a theory, but that's a little bit, often that's quite a grand claim. So instead, let's call it a theory fragment. Okay, we have some new insight that we can add about what that solution is going to do for solving the problem. Let me give a concrete example. So here we have a problem. I'm working in a company, and everybody's complaining, you know what, developers are just writing code that is not secure. So we decide, okay, let's understand this. Let's do a survey and try to find out why this is. And so from that, we see that the tools that the developers are using, that basically are giving them constraints. They're trying to stop them from doing the bad thing and writing code that shouldn't be using an API or whatever. And, but we find out from the developers that they actually appreciate getting that advice, but they don't know what to do. They don't know the alternative. And so if they spend time trying to figure that out, that's going to slow them down and they're not going to ship their code on time. So now we've kind of identified the problem. And so from this, we can come with a solution. And I'm making this pretty kind of high level here, but we redesigned the tools that give more guidance on how to actually make your code more secure according to the constraints that you were given. Then once we validated it, now we have a theory fragment that says developers write non-secure code when their tools made it too difficult to do the right thing. Tools that give more training support will lead to higher quality code. So this is our theory fragment, and we can use that to argue about why we should use this tool or why we should use this tool over another tool. I started at the left-hand side saying that we should start with the problem understanding, and it kind of implies that then we go to the solution. But paper goes left to right in our culture and top to bottom. We could actually start on the other side, and in fact we often do. Generative AI is a great example. We have this cool tool. What problems can we use it to solve? Let me look at that. That makes a lot of sense, though. There's opportunities for how this new technology can be applied. Developer portals as well. That is something that we're just seeing now. Oh, it has all these possibilities. And maybe there are some ways that we know how they can bring value, but maybe we can understand what other problems could developer portals address. I'm particularly interested in this community aspect and how developers share knowledge. Can we look at that? Later on, I'll come back to this with more insights on this part. So I've talked about theories so far. I haven't really talked about specific theories of developer productivity, and there's a lot out there. And I've done some work in this. I'm just going to share some insights of these theories of developer productivity. So the first one that I looked at when I was working with Microsoft is looking at what are the factors that make developers feel more productive. And of course, when you're doing research like this, you're not starting in a vacuum. There's stuff we know, right, from other fields or maybe from within the field. And so we started with this theory that says, look, if workers have higher job satisfaction, then they are going to be associated with increased levels of employee productivity, lower turnover rates, and better overall organizational performance. So this was a theory that we built on top of in our study. And we basically, from doing a literature review and talking to lots of developers, doing interviews, we discovered a lot of factors that could impact their satisfaction and their sense of productivity as well. And during that work, once we gave the survey to the developers using all of those factors, we found that some of these cluster together. So this came from our analysis, building regression models and doing hierarchical clustering of these factors, that some of these things go together. The details don't matter so much, but just some of the highlights. You know, it wasn't just the engineering system. It was other things, like being an important contributor, their culture of their work, the environment they work in, and the fact that they feel like they're doing impactful work. These ended up being important clusters. And then the way that our regression models showed us is that there is this bidirectional relationship between developers who feel satisfied at their work and developers feel that they have high productivity in the work that they do. So that means that if they are productive, they feel happier, and if they're happier, they're going to feel more productive. And these other lines at the bottom and factors at the bottom, these are kind of the mediating or the influencing variables on these feelings. And you'll see that work culture impacts developer satisfaction. It doesn't directly impact perceived productivity, but indirectly it does. And impactful work was something that really just affected both. Engineering system affect perceived productivity. So this gave us this theory about developers that feel satisfied, why they feel satisfied, and developers that feel productive, that there is this relationship between these factors. Now, I'm not going to go into this in too details, but there are other studies out there that show similar kinds of things. So Graciotin et al., they looked at developers that are happy. Okay, happy isn't quite the same as satisfaction. You can ask me why later. But they found that developers who are happy also felt like their work they felt more productive, and they also felt that their work was higher quality as well. Murphy and Hill et al., they also found a lot of factors, and they showed that some non-technical factors such as job enthusiasm and peer support and feedback about their job performance were actually higher at predicting perceived productivity than some of the other technical factors. And Catherine Hicks et al., they looked at a theory of developer thriving, and they found that factors such as having autonomy and feeling like you could learn, these are factors that when you feel that you have good support in those also lead to higher productivity. So look, we know a lot now about all of these factors that lead to higher productivity that are social, if you like. Okay, thank you for staying with me so far. Okay, that was the hard part. Okay, so now we have what are theories. So now let's talk about what are frameworks. And by the way, some of you might even disagree with me about the definitions that I'm using, because it's a little bit of a free-for-all out there, but there's a lot of people that agree with the definitions I'm giving. So what is a framework? So a framework is basically, it denotes a structure of categories. You can think of it like an overview, like a plan. And it defines all of the variables, all of the constructs, all of the relations that we have between them. So you can think of, when I was talking about developer satisfaction and productivity, some of those variables, maybe things like enablers of their work, or challenges in their work, or barriers in their work. Now, so far you're probably thinking, that kind of looks like a theory, pretty close, But frameworks, they don't provide explanations, okay? They only just provide what are all of the things and what are all of the possible relationships that we need to care about. And my colleague, Elise Paradis, put me onto the second paper that's referenced here. She talks about that frameworks, the really cool thing about them is, or the word framework, is that it has the word work in it, because frameworks are only really useful if you put them to work. So you can use a framework and pull out the constructs and the relationships from it and put it to work by maybe trying to apply it or trying to discover a theory or think about it in terms of a theory and see what you can learn from it. So frameworks, put to work. Remember that one. This is an example of a framework that some colleagues of mine came up with in 2008. This framework came from a systematic literature review of a lot of other papers that did studies of motivation in software development. A lot of papers on that topic. And they came up with all of the factors that they pulled out from all of these different papers. So they have all of the factors of intrinsic motivation, as well as a lot of the factors of extrinsic. So, being paid, having good work-life balance, those may be extrinsic. And they also identified some interesting intrinsic factors that are specific to software engineering. So what it's like to work in your team, doing experimental work, and so on. And the development process itself is an intrinsic factor for many people. So this is not something you can just go and use without thinking about how you're going to apply this. And which of these factors are you going to look at, and what question are you trying to answer using it? How many people here have heard about the SPACE framework? Yeah, a few. So I'll just spend a minute talking about it. So this is a framework that some colleagues and I, so Nicole Forsgren, Chandra Medilla, Brian Hauk, Jenna Butler, I'm mentioning all of these people because they're all important. We all got together and we thought about, what are all of the different factors that matter when we're thinking about developer productivity. And we did this at a time when developers had just switched from working in the office to working from home. And we saw a lot of focus on what we call activity metrics. So, oh, look, our pull request rate is still the same. Oh, look, the number of lines of code in our system is still the same. We're good, right? No, we weren't good, right? A lot of people were burning out. There were a lot of issues. And from all of the research that we had done, we realized that productivity is really complicated. And so we came up with this framework that has these 5 different dimensions. And the first one is satisfaction and well-being of the developer. Performance, there's a lot under the performance bucket. The quality of the code, the impact that you might have, how much money an organization makes. Activity, lines of code, pull requests, code reviews done, so on. Communication and collaboration, we pull this out as a dimension because software development is a team sport. It is a community event to write code these days. You need to be connected to your team and to the community, and if you don't have that, you're not going to be building the software, right, that we have today. So we pulled out communication and collaboration as a separate dimension, as well as efficiency and flow. How efficient can you be, and what kind of flow are you going to have through the system? Now, it is a framework. So in the paper, we did suggest, choose 3 of these dimensions. It would be better than just counting pull requests or lines of code. At least look at these other things and see what's happening when your developers are working from home or when they adopt a new tool. But it's not quite that simple, and maybe we didn't emphasize this enough in the paper, but these dimensions are not independent. So when we make a change to one of them, we may have a change, or when we make a change that impacts one of the dimensions, we may actually influence another dimension as well. This is not in a paper, but I put a link to a talk that I gave about pandemic studies, because I looked at the different papers that were giving insights on what happens when developers work from home. And I looked at the results that came out of these papers using the trade-offs, the relationships between these dimensions. And you can see a lot here. Yes, it's great if developers are helping each other when they're working from home because they need that help. Teams should always be on. Slack should always be on, but now they don't have that focus time and they feel like they're constantly being interrupted and they don't have that. So thinking about those trade-offs is really key. Another framework, Abhi Noda is here today, and he'll be talking about how we put this framework to work. So the DevX framework came from a set of interviews that we did with developers across the industry, and we found what are the factors that influence a developer's sense of experience. You may be wondering, what do we mean by experience? Oh, so many words. We always need to be defining them. That's a construct. So the way we think about experience is how developers think about, how they value, and how they feel about their work. That's developer experience. And so we asked these questions, and we found these factors, and we found that which ones matter depend on the context. So if you're a new engineer, which factors are going to influence you are going to be very different to if you are more of a seasoned engineer. And then we also found barriers to improvement, strategies to improve their experience that developers took, and then coping mechanisms, such as, you know what, I'm just going to look for another job. That's maybe not a coping mechanism you want, but that was one of the ones that we found. So putting this to work is something that Abby Noda has done at DX by using these factors in the Get DX tool and coming up with the Developer Experience Index, which I hope he'll talk about later. Okay, that was frameworks. Now let's get to metrics. How are we doing on time? Am I good? All right, so the SPACE framework, right? So it's been used for defining a lot of metrics. By the way, SPACE framework for thinking about developer productivity metrics is not the only framework. There's the COMS framework, there's GEMS, there's ease, speed, quality. They all offer something. They're all useful because they make us think about these different dimensions. I'm just going to pick on SPACE because I'm one of the authors of SPACE and use that here. So one of the things that I did with this was just a little bit of a thought experiment. I kind of read a bunch of stuff. I looked through a lot of websites, and I thought, okay, what metrics are being used by productivity dashboards in industry? And Abby also has a report on his website that lists these different metrics. And how do they kind of, line up with the different dimensions of SPACE? So quite a few dashboards do have questions that ask developers directly, how are you doing? Are you satisfied with your work? How engaged are you? But there's very few that go beyond that, one or two that do, but most of the time it's sort of one question that asks about these things. Performance, even though it's so important, there's not a lot on the performance, the quality of the product. Activity, there's lots there, very few on collaboration. Very few metrics are looking at collaboration. And most of them that are looking at code review. Yes, that is collaboration, but there's a lot more to collaboration. Helping each other, is an example. And then efficiency is, it's the one where lots of our metrics are really hyper-focused on the efficiency of what we're doing. And of course, that is important. It's easy to measure, too. And it's easy to argue, maybe, that we need more money for certain things in an organization, but it's not the only one, and we need to be sort of paying attention to these other metrics. So for example, let's go back to that security constraints example, scenario that I gave you earlier. What dimensions, if you were looking at that, which of these dimensions do you think you might care about? So I'm going to propose some metrics here, thinking about these 5 dimensions. So the first one is, what is the number of vulnerabilities? If we make a change, we add this new tool, do the vulnerabilities actually go down? But we might want to also care about, does it also reduce developer frustration? And we might want to think about, using that guidance, maybe that impacts the number of deployments. Maybe it slows the developer down. So we want to look at efficiency. So again, using SPACE to think about this systems thinking, we'll hear about that soon. Thinking about the metrics in a systems kind of way, right? Not just as individual metrics. But we need to come back to the theory as well. So I showed you the theory fragment earlier, and here I'm mapping these metrics that we pulled using SPACE and relating them to this theory. And what's nice about doing that is that we get to add some more nuance to our theory if we look at those different metrics. Oh, not only is using that tool reducing the number of vulnerabilities, but it is decreasing frustration. And you know what? It's not affecting the number of deployments. So now our theory fragment is a little bit richer based on thinking about these different metrics that we considered, if you like, different questions to ask based on the SPACE framework. So here are some questions we need to ask about metrics. The first one is the most important, and sometimes I think we forget about it. What is our goal, our theory, that drives the use of that metric? And really, does the metric add extra information at all over what we knew? So one of my hard-earned lessons during my PhD was I created a tool that gave insights to developers about technical debt in their code, and they said, thank you very much, that's lovely, but we already knew that. Tell me something I didn't know. I'm like, okay. So, when you think about metrics, often we know what are the pain. Slow builds, we know. Everybody complains about them every day. Do we need a dashboard? Not sure. Who uses the metrics? So thinking about, is it the developers? So a lot of what I'm trying to portray through this talk, and I think I'm missing it a little bit, is that it's important to think about the developers, the lived experience of the developers. This is what we are trying to improve after all. Are they using these, or do they look at them and feel afraid and feel threatened? Or do they actually see themselves? Do they see their pain points when they look at these dashboards of metrics? Why are the metrics used? What decisions are going to be made? Are they really going to be used for decisions? Can we really make those changes? Or are we just creating that overview so we can kind of see what we're doing and we feel comfortable with that? Sorry, I'm being a little bit controversial on this one. Where are they used? Dashboards, reports. When are they used? Are they used in retrospectives? Or are they used in our daily stand-ups or different meetings that we have, maybe monthly meetings? And how are they used to drive decisions? Are we tracking how these metrics are actually used to make change? And then when we make the change, are we then asking, what did that lead to? Did that move the needle on some of our metrics? Does it even change now the metrics we should be looking at? Because we've made this change, some may no longer be relevant and new ones may be. And actually, I was at DPE a couple of weeks ago, and Atlassian have this 5R framework, which I absolutely love. So I put a plug to it here. You can look that up as well. All right, so I'm into the last part of my talk, and I think I'm good on time. So let's look at the future developer experience dashboards, or the future developer productivity dashboards. I kind of have a problem with the word productivity. You might have guessed that by now. So I'm using the word experience, but let's also use the word productivity. So no talk would be complete without a ChatGPT-generated picture. So these days, right? So I generated a picture. I asked ChatGPT, after kind of feeding it some of the stuff that I was thinking about, to generate for me, what did ChatGPT think this developer experience dashboard of the future look like? And this is what it produced. And I'm like, oh, it's kind of pretty. Maybe there's a bit of VR in there, maybe augmented reality stuff in there. But you know what? There's no developers. Right? I actually asked it to produce one with developers, but I'm not going to show that because there's another reason why, which you can ask me later. But when I look at this, and then I think about the developers that we're trying to help, the lives of developers, that lived experience, the pain points that they feel, it feels disconnected from this, right? From truly understanding what developers within teams and organizations really the pains that they're facing every day and how we can help those. So I think the future developer experience, actually this is aspirational. This is what I hope the future of developer experience dashboards will look like. Will they help us not just measure what's going on, but will they really help us understand and improve what it is that we're doing? Really that deep understanding. And really know from that understanding what improvements we can make. And I underlined people because it's really about people, at least so far today. Maybe in the future, people may not be as much writing code as today. But people use these processes and tools to create excellent products. And we have some cool capabilities coming ahead. So we have AI, right? Nobody today can say that it's not incredible. The opportunities it's providing. And we're going to start now seeing more AI-driven insights and capabilities being added to these dashboards. There's some research coming out on this already. And in a way, that's kind of nice because it makes us think more about the underlying data and the queries that we want to make rather than the metrics themselves. So the metrics are kind of, right now what we're using because we don't have such rich capability to be as flexible as we might want. The other thing that maybe I'm being a little bit aspirational here as well is that maybe we'll have more theory-driven insights. So in case you didn't realize from what I was showing earlier, theory is hard. Developing theories is really, really hard. And maybe the AI can help. It can help see these relationships. It can see what's happening and suggest these theories or give more evidence for theories we thought we understood. And there may be more self-serve customization and role personalization, as well as this self-healing. But if it's self-healing and it's not just changing how the dashboard looks like, but actually is also then making changes in the system that the developers are using, what values are we going to be giving there? Is it human or system values? Yeah, and so, I didn't expect to end up here when I started working on this talk, but I'm like, oh, that sounds like a developer portal. So maybe the future of developer experience dashboards is really the developer portal, and I'm in the right place after all today to be exploring this, because really we shouldn't be kind of thinking of them separately. I said I would come back to the developer portal theory. So this is an example of that, and thinking about what are the new tools that can help developers be productive. That is something that we've noticed in some research, that developers often don't know about the new tools. I've noticed it in industry too when I've talked to people, developers, and they're talking about pain points, and I'm like, but there are all these tools that do that, and they didn't know about them, and their colleagues were using them. So maybe the portal will help with that and help us to, this theory also helps us decide which metrics we should be looking at. But what problems or opportunities do we not know about yet? We're just at the beginning, right? So this is kind of an obvious one, but there are new things we should be thinking about. Just wanted to finish with a plug to two of my students, Artie Starr and Alessandra. Artie is working on a theory of momentum and troubleshooting, and Alessandra is working on dashboards, trying to improve dashboards and how they're used for bringing insights and making decisions. Talk to me later if you want to connect with them. We like to work with industry. I didn't put a link to myself. That's okay. My students are better than me, so connect to them. And then just a plug for Bridges, which is something Justin, and thank you, Cortex, is helping support as well, which is this online unconference kind of thing that we're doing. And Max, who's going to be chatting later today, I'm going to be at his roundtable, is going to be presenting for us next month on November 12th. There's a QR code there. Sign up. It's going to be great. It's in a new virtual reality environment for us to work in. And with that, thank you very much for your time and attention, and pass it over. Thanks. Thank you. Thanks.
That was incredible. I'm going to go a little off script here. I know we have 7 minutes left. I'm going to try and keep it quick. We were so honored that Peggy accepted this opportunity and came to talk at IDPCON because, as startup founders, sometimes we're so focused on just the raw pain. It's like there's this problem out there, and we're just gonna beat it to death until we solve that problem. And I think it's always good to take a step back and say, like, what are we actually solving? And thinking about it in this framing, I think gives us so much insight into the problems that we're solving, how they impact developers, how they impact business, and it gives us new opportunities to go and look at new fields, new things. And I think developer portals are so exciting. Like, as she mentioned in that last slide, it's an opportunity to bring all these things together. It is about people. It is about process. It is about products. It's all these things coming into a single place. And how can we use this to drive excellence across the organization? And so, yeah, really excited. We wanted to start off this conference starting with the theory and the frameworks because it helps us understand what are we actually doing. And I think when academia and research and industry come together, magic happens. And so this was a great fitting start to the conference. So thank you so much again. And so, kind of taking that a little bit further, the future of software practice. I think as we've learned more and more about developer experience and what our customers and organizations in the world are trying to achieve, we kind of keep coming back to this theme of engineering excellence. And engineering excellence means a lot of things to a lot of organizations, but that's kind of the common theme that we hear. And engineering excellence and developer experience are inseparable. You can't have one without the other. And so talking about engineering excellence, we kind of break it up into these different areas, right? We hear themes around, hey, we really want ownership and accountability. We want people to, you build it, you own it, you run it. Or reliability and operational excellence. We want to build products that are reliable because our customers expect that from us. We want to build products that are secure and compliant because that's what really matters in this interconnected age. We want to do things with standardization and guardrails. We want to make it easy for developers to do the right things. We want to do things in a consistent way. And all these things kind of fall under this idea of engineering excellence. And organizations may care about different aspects of this over time. Right? An organization may be really focused on security, like we were talking about earlier. And that may shift to reliability, or you may focus on different things in different parts of the organization. But it all kind of falls under this bucket of engineering excellence. But you can't enable engineering excellence without developer experience. At the end of the day, your developers are the ones actually hands-on doing work, building features, writing code. And so if you're not enabling your developers to actually hit those 4 pillars above that, then what are you doing? Like, developer experience is fundamental to achieving your engineering excellence goals. And on top of that, you apply these 3, the things you kind of see here at the bottom. In order to drive engineering excellence, in order to build a great developer experience, you have to do it in a data-driven way. You can't just throw things at the wall and see what sticks. Like, are you actually improving things? Like, what is that process? Are you thinking about this from a culture of continuous improvement? And we'll talk about this in just a second, but engineering excellence is not a state. You're not excellent or bad. It's a culture, right? You're continuously improving. You're continuously getting better. And so do you think about engineering excellence and each one of these things as a path of continuous improvement? Are you getting more reliable? Are you continuously improving your developer experience? Are you getting more secure? So it's this path of continuous improvement. And the last thing, I think this is really important, is org-wide visibility, right? It's not just enough to create some dashboards and have your VPs look at it or some tech leads or SREs look at it. You want the entire organization to understand, what are we trying to accomplish? Like, what does excellence look like here at the organization? And how do each of us work towards that path? And I think you called out one of your students thinking about like personal developer dashboard analytics. Like, for me as a developer, what do I care about? What does the organization care about? What does the business care about? We all have to know what we're working towards, and this all falls under the bucket of engineering excellence. And so today, welcome everyone to IDPCON. I know we didn't say that again, but I'm really excited. This is the first inaugural IDPCON. When we started Cortex 5 years ago, there wasn't really anything called an IDP. We started really with that core pain point of like, I'm a developer and I have no idea what's out there. We have services named after Game of Thrones characters, and you're on call and you get paged at 2 a.m. and you're digging through Confluence and trying to Slack people, and it's just absolute chaos. How do I get out of this hell? And that's where Cortex started. And over time, as we've learned about the space and we've learned about all the different problems that we can solve, we've landed on this concept of a developer portal. And I think it's enabled organizations to do so much. And I think what I'm really excited for today is hearing stories and lessons from world-class engineering organizations who have gone on this journey of engineering excellence, who are in different parts of that journey, who've learned different things, and we have some really, really excellent speakers from a wide variety of companies and industries talking about aspects of engineering excellence today. And I think what you'll notice as you go through these sessions is that there's a kind of cohesive, there's a synergy between all these talks, right? They're all talking about their journeys towards engineering excellence over time. And I think that's what we're trying to get away from this, right? Is like I mentioned, engineering excellence is not an end state. It's a continuous improvement. It's a path. It's a journey. And what we want to learn is, how are the world's best engineering organizations going on this journey? What are they focusing on? How are they continuously learning? How are they getting better? And of course, where do IDPs fit into all of this? So really excited for today, and there's a lot of really great people here. Make sure I hope you guys learned something from today. Had an opportunity to network with people and just learn, how do we all strive towards engineering excellence? Thank you so much. Really looking forward to the conference.